Hello my people, this will be the third and the final video on mean value theorem. Let's go ahead and just jump into some examples. Say we have f of x is equal to the square root of 2 minus x, and they're asking you to evaluate it on the interval -7 to 2. Now these questions, when they're presented in the book, are oftentimes establish that the mean value theorem applies and then find your C value. They're trying to coach you along and trying to make sure that you remember to establish make sure you establish the hypotheses and confirm the fact that it is continuous on the closed interval and differentiable on the open interval. Now remember that this is basically a radical function that it has a y-axis reflection and it's moved to the right 2 places, okay? Because remember, you can actually, negative x minus 2 to the right 2, and then x equals c reflection, what we usually refer to as a y-axis reflection. And the implied domain is negative infinity to 2, okay? So remember, if it's continuous on the implied domain, it's definitely going to be continuous on a subset of that, right? Because the only difference between this and this is this stops at -7 and this keeps going in the negative direction all the way to negative infinity. Okay, so we've confirmed the fact that f is continuous on -7 to 2. Now the next thing that needs to happen is we need to determine that it's differentiable on the open interval. Okay, and f prime of x is going to be equal to 1/2 2 minus x to the -1/2 times -1, or -1 over 2 times the square root of 2 minus x. Now this radical is the same as that radical, so it's still going to give you this domain, but the thing is that it no longer can include 2, because 2 wouldn't violate the radical, but it would violate the fact that it's in the denominator. It will turn the denominator into 0. Okay, so this f prime has an implied domain, okay, of negative infinity to 2, non-inclusive. So, but you're not really worried about that because you want f to be differentiable and therefore f prime to be continuous on the open interval, and that indeed is check. Okay, now what needs to happen is we need to find the average rate of change. Now if we want to find the average rate of change, okay, that's going to be f of 2. Well, f of 2 is going to be root 2 minus 2, and then f of 0 is going to be f of 2 plus 7, all of that over 2 minus a -7. Okay, well, that's going to wind up being 3, okay, 3 over -3 over +9, or -1/3. Now, does that make sense? Well, it should, because you should know that the the graph looks something like this, and therefore an average rate of change is going to have a negative slope, and it's going to be a very slight slope. So -1/3 sounds about right. Now that I have f prime and the average rate of change, and I know that both of the hypotheses are confirmed, I need to set this equal to that. Okay? Well, if I have -1 over 2 root 2 minus x is equal to -1/3, well, that's kind of nice, the fact that the negatives cancel out. You can basically, reciprocalize both sides. And you're left with root 2 minus x is equal to 3/2. Well, let's go ahead and square both sides, 9/4, and I know that x minus 2 is equal to -9/4. And therefore, what we have here is x is equal to 2 minus 9/4, or -1/4. That's your C value. And of course, you could be a little bit more formulaic about this and actually put C right there instead of X. And that actually probably would be a little bit more official, but you get the gist, right? You're basically setting the variable expression that represents the instantaneous rate of change equal to the average rate of change, and then just solving for the variable. Okay? Now, -1/4 makes sense. It's in the interval, so we're good to go. Okay, let's go ahead and do another example. In this one is going to be a little bit more difficult. We're probably going to need to employ just a little bit of calculator work. So that's y is equal to x natural log x, and we're going to go ahead and do it on the interval 1 to 2. Okay. Now, x natural log x. Now, you know that the limiting factor is going to be the natural log x. It has an implied domain of 0 to infinity. But this is a subset of that, so that's not really going to be an issue. And of course, multiplying it by x isn't going to diminish its domain at all. So you know that y is continuous on the closed interval. Check. Okay. Now I simply need to take y prime, and you get x times 1 over x plus 1 natural log x. Okay? And that winds up being y prime is equal to 1 plus natural log x. Well, that's okay because that means that y is differentiable on 1 to 2 on the open interval, right? Because it hasn't shrunk the domain in taking the derivative. That domain is exactly the same as that domain. And both of those domains include the closed interval, so it certainly includes the open interval. Now, I need to find the, I need to go ahead and find the average rate of change. So the average rate of change is going to be 2 natural log 2 minus 1 natural log 1 over 2 minus 1. Well, natural log 1, as we should remember, is 0, okay? And therefore, this is just 2 natural log 2, or if you want to sort of shorten it up a little bit, you can just call it natural log 4. That's because, properties of logarithms, you can pop that 2 up and just, it makes it a little bit nicer and neater. Now, this is your average rate of change. This is the variable expression representing your instantaneous rate of change. And what you need to do is you simply need to set them equal to each other. And that's natural log x is equal to natural log of 4 minus 1. Okay? And then we basically need to exponentialize both sides. X is equal to e natural log 4 minus 1. Okay? Which of course is just it's just 4 over e. And you can, find the decimal approximation for that, but that's 4 over 2.7, so it's a little bit more than 1. Okay? Now, it's between 1 and 2. That's definitely on the interval. We can go ahead and, actually, let's go ahead and find out the exact value of 4 over e, just mainly because I'm curious. Let's go ahead. 4, and of course the e that doesn't have the exponent is over here. It's over here on the division symbol right here, so e, and that winds up being 1.472. Okay, so 1.472. So at 1.472, which we know is 4 over e more precisely, the slope of the original function is going to be equal to natural log 4. Okay? Which of course would make the tangent line at that x value parallel to the secant line, which is what we have right there. Now let's go ahead and do several Rolle's theorem problems, and we'll actually run into a couple of things here that'll help us sort of firm up our understanding of both of these. Well, it's actually a theorem and its corollary, but whatever. So let's say we have f of x is equal to x minus 1, x minus 2, x minus 3, and I want to find out whether, first of all, whether Rolle's theorem applies, and second of all, if it does, what value on the interval has a 0 slope like the average rate of change. Now, Rolle's theorem, if you remember, has the same two hypotheses that the mean value theorem does, but it adds another one, okay? So first of all, we need to determine that this definitely is continuous and differentiable on 1 to 3. Continuous on 1 to 3 inclusive, and differentiable on 1 to 3 non-inclusive. Well, this is a polynomial in factored form, so that really shouldn't be that big of a deal. F is indeed continuous on 1 to 3. F is indeed differentiable on 1 to 3. Check, check. And here's the thing, they gave it to you in factored form to make it very, very easy. F of 1 is equal to 0, which is equal to F of 3. Cha-ching, okay? So the outputs are equal, so you know that all three of the hypotheses are actually taken care of. So when we go ahead and take the derivative, and I would go ahead and suggest in order to take the derivative that you go ahead and just multiply this out, and that's, yeah, because I don't want to wind up doing the product rule. That's just obnoxious. X cubed minus 3x squared plus 2x minus 3x squared plus 9x minus 6. Okay, all I did was multiply the x by those three terms, the negative 3 by those three terms, and I'm left with x cubed minus 6x squared plus 11x minus 6. So my f prime of x is going to be 3x squared minus 12x plus 11. Okay? Well, when is that going to be equal to 0? I'm so glad you asked. 3x squared minus 12x plus 11 is equal to 0. Okay? Now, I know that this breaks up into 3 and 1, and this breaks up into 11 and 1. So basically, what needs to happen is it actually needs to be able to be factored. So 3x, that is correct, isn't it? I'm thinking so. Plus 9x minus, yeah, okay. I'm just making sure. Okay. If it splits up like this. Now you can put 11 here and 1 here, but they have to both be negative, right? And if they're both negative, that's just not going to happen, okay? Because you need to put 11 here and 1 here, and that's going to be 14, okay? Well, that's not that big of a deal. I know how to complete the square, and I know how to use quadratic formula, so that winds up being negative 11, okay? And then we can go ahead and go x squared minus 4x is equal to negative 11 over 3. That's plus 4, and of course that's x minus 2 squared is equal to, well, that's going to be 12 over 3, and that's negative 11 over 3, so that's 1/3. We get x minus 2 is equal to plus or minus the square root of 3 over 3, or x is equal to 2 plus or minus the square root of 3 over 3. Now, there's only one of those that is on the interval, okay? And it's 2. Actually, both of those are on the interval. Yeah, because that is approximately 0.577. And so that's 2 plus or minus 0.577. Remember, because we did it a couple problems ago and we wound up with that approximation. And therefore, it's approximately, 1.4 and 2.6, both of which are on this interval right here. Okay? And actually, I'd like to kind of see that. So let's go ahead and take a look at that. Let's go ahead and just put it in factored form, just like it's given to us. So x minus 1, x minus 2, and x minus 3. Okay. Now we know that it's going to be from 1 to 3, so let's go ahead and go to our window, and x is going to be 1 to 3. You know that it's going to, well, let's go ahead and just graph it. We see that it's going to be above the axis, and it's got zeros at both, at 1, 2, and 3. So let's go ahead and change the window again. Let's go down to y and go from negative 1 to 1. And when we regraph it, we see that it's actually going to have two places where it's going to have a horizontal tangent line, which is exactly what we're actually shown in our analytic work. It's going to have a horizontal tangent line right there. It's going to have a horizontal tangent line right there. Now, the Rolle's theorem guarantees that there's going to be 1. There just happen to be 2 that are on the interval as well. Okay. Let's go ahead and do one more example. Now, we did one kind of like this, or with a related function. We have y is equal to x to the 2/3 minus 1, and it's going to be negative 8 to 8. Okay? Now, when I plug in, now remember, when x to the 2/3, that winds up being an even function. So when I plug in negative 8, I'm going to get the same thing as when I plug in 8, okay? Because I'm going to take the cube root and then I'm going to square it. So negative 8 to the 2/3 is 4, minus 1 is 3. 8 to the 2/3 is 4, minus 1 is 3. Okay? So we already know that that third one, f of negative 8 is equal to 3 is equal to f of 8, is satisfied. Okay? We know that it's x to the 2/3, so we know that f is continuous, right? There's nothing to say that you can't plug in any old number that you want. The problem comes in this second one. F is differentiable on the open interval negative 8 to 8. And I'm here to tell you that that just is not the case, okay? And the reason is that this function does this number. It kind of comes in and does that number, right? And so if you're out here at negative 8 and you're out here at positive 8, you have these 2 points right here. And you have the average rate of change right there. But is it ever 0? Is the instantaneous rate of change ever 0 between those points? No. Could it be? Well, sure, it could be, but because f is not differentiable, Rolle's theorem doesn't apply, and therefore there's no guarantee that, that there's a point in this interval that has the same slope as the average rate of change, okay? So one of the hypotheses fails, and therefore it does not apply, and you basically just say Rolle's theorem does not apply, or mean value theorem doesn't apply, because f is not differentiable on negative 8 to 8, non-inclusive, okay? So that would be how you would state something where the hypotheses are not held up, and therefore Rolle's theorem or mean value theorem does not apply to that particular scenario. I hope that is clear enough in terms of mean value theorem and Rolle's theorem. Shoot me an email if you have any further questions, and I will try my best to address them. Bye.